Okay, so here's my suggestion. It's tempting at this point to put the centers in first, but here's what I would suggest. Don't put the centers in as of yet. The reason is because if you put the centers in, there's a certain kind of parity, the floppy parity, that you can get with any of these edges, that if you fix the floppy parity, you're going to put the centers out. Now you can easily put the centers back in, but my contention is why put the centers in just to have to put them back in when you potentially have to fix a floppy parity. So the way to look at it is there's actually three types of parity I think that we can distinguish. There's the even layer parity, the floppy parity, and the brick parity. The even layer parity is going to be demonstrated by this. So here's a strict even layer parity. Right here. So a strict even layer parity is where you have two edges that have to be swapped. You don't get this with a normal 3x3 because if you count these as edges, that would be an odd number swap. You just have to swap these two here, just one set of swaps, and you can't get that, but because these are actually four pieces, this represents an even layer, these two and these two. So because of that, we call this a parity because it's an impossibility if you look at these as edges, a parity problem. But it's not really against the law of cubes as a four layer or as an even layer puzzle because you can swap these two and these two. That's two sets of swaps, so therefore it doesn't break the law of cubes. So when you see a symmetric swap that has to happen between pieces, in other words, taking a look at this, all four pieces have to be swapped. So if you have four pieces that need to be swapped, that's a strict even layer parity, and that's managed by the URF algorithm, which is holding these at opposite sides, 2U, 2R, 2F, then you do a 2U, and just above that, 2U, and 2F, 2R, 2U. So even layer parity is when you have four that have to be swapped. 4 of the 8, and that makes it easy. So a brick parity is where you have 3 that have to be swapped. Here's what I mean by that. Hold this here. So something like this. What you see here, I kind of did the edges a little different, but if you just take a look at this section over here, if these two and these two, in other words, a section of 4, a set of 4 were off, then you'd have a normal even layered parity. In this case, this is all fine, so this is good over here. We've got one that's off over here, one that's off over here, and one that's off over here. If 4 are off, that's considered an even layer parity, and that's fixed by the URF algorithm. If 3 are off, just like this, then that's going to be, in essence, what a brick parity is. So these are fine. We have 1, 2, 3 that are off. That's a brick parity. So in order to fix the brick parity, what we do is we do the brick parity algorithm, which is kind of a longish algorithm, but is really intuitive in any case. So I'll just kind of go through with this. You don't get this kind of parity as a problem with a normal 4-layer. This is just to demonstrate it. And that's because we have ways of putting these in no problem. But we don't have as easy a time when we have bandaging over here. But just to go through that, if you're finding that it's on the right side, you organize it to where the brick parity algorithm will take this piece, we'll move this to here, this will come back over here, and this will come here. So we just line things up where they're supposed to be. So this is going to be yellow and blue. This is going to come here. This is going to come over to here. So I got to take this one and put it behind. So this will come here. This green and yellow will come here. And this blue and white will come here. And what that's going to be, what I'm going to do is this is going to be defined as U. I'm going to define this as an F, just because it's going to be as similar to this as possible. This is going to be R, and this is going to be L. So that's going to be, start off with a 2F, then we do U, 2R, UI, 2L, U, 2R, UI, 2L, do a bridge of 2F, then we do our middle 2R. This is where we had the initial, one of the initial parity position anyway, so we do that 2F, then 2R, 2F, and then finish it off with a 2L, U, 2R, UI, 2L, U, 2R, UI, then a 2F, and 2L. What's going to happen is we can just move this back. it's going to do all the exchanges and everything will be fine. You see that in this particular puzzle, it messed up the center here, which we can easily get back. But this is why we want to do the edges before we do the centers. We can even do these edges before we do anything else. Now that's on the right side, so you can see we can get this back. Like so. There's also a left-sided version, which looks like this. So you can see it's the left side that we're going to be exchanging around. So find where we have to make our 3 cycles. So this blue and yellow should go here. This green and yellow should go here, so this moves to the back. So the left-handed version, this will go here, this will move here, and this will move here. So if we see it on the left side, we do just the inverse algorithm with that, which is against our with a 2F. And now we do a UI, 2L, U, 2R, UI, 2L, U, 2R. Do a 2F, and then we do a 2L on this side, 2L, 2F, then finish it off this time with a 2R, UI, 2L, U, 2R, UI, 2L, U, then a 2F, and a 2L, middle 2L. And that'll get this back, and you can just position this back here. This part can easily be fixed. Turn, 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 and turn. So as demonstration, that in essence is what a brick parity is. So to summarize, if you have 3 that are out, then it's a brick parity. So 4 that are out, that means these 2 must be in. So this is just your typical even layer parity. 3 out, which will be in 3 different corners, you do a brick parity. When you have 2 that are out, well, that's your floppy parity. So that looks like this. Okay, so there this is. You see this is in and this is in. But in here, instead of 4 being out, just 2 are out. When 2 are out like that, this is a floppy parity. Now again, normally this wouldn't be too much of an issue with the 4x4, but because of the bandaging it is. So 3 out, brick parity, solved by the brick parity algorithm. 2 out is a floppy parity. Now this looks like it breaks the law of cubes, right? Because I have to do an odd number of swaps. Even with a 4 layer, you can see these 2 need to be swapped. It's just 1 swap. But in reality, it's not just these 2 that are going to be swapping. At the end of this, these 2 will swap, but also these guys are going to be switching positions also. Which is why when you get this, the centers are going to necessarily be messed up after you do the fix with this. So the fix with this is doing the floppy parity strategy, which uses the RedBull algorithm 3 times. So what you want to do is put these opposite each other, take this one that's opposite here and just move it down over here. So do like a 2B. Then what you're going to do is just do a RedBull algorithm which will swap these 2. So that's going to be 2R, 2B, 2U, L. 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. What you're now going to do is you're going to do a 2L slicing through this side. What it's actually going to do is it's going to bring this one up to here. So 2L, now do the RedBull algorithm again, and that'll swap these 2. 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. After doing that, do a 2L one more time, and you're going to find that when you do that, these 2 are now going to match, and these guys are going to be matched as well. They're going to be matched but upside down. Just do one more RedBull. So this is the 3rd one. 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. And now you can do a 2B to bring this back, and you can see that these 2 have been swapped. But there's a price to pay. These guys also did some moving around, so we have to fix the center. Just put this into fixed position. Move this here, here. Fix it any way you want. We'll get more into that in a bit. And now we're going to put this one in. Going to move this in with a 2L over here. Do a U to move it to the R position. And just swing this back here. Okay, so that covers all the different parity situations. If you didn't want to do this by reduction and you don't mind parity, there's the even layer parity, where you have 4 that are out, 4 of the 8. There's the brick parity, where you have 3 of the 8. And then there's the floppy parity, where you have 2 of the 8. So, I mentioned that because now we're going to be searching for this. You can see what it did to the centers, which is why I do this first. So let's take a look at this. How many are out? Is it just 2? Is it 3? Or is it 4? Well, what we're going to do is you can see that none of them are in. So let's just make a turn to where we get at least 1 in. So I'm going to make a turn. I see this is in. This is in. This is not, and this is not. However, you can see 2 are out. So what kind of a parity is this? This is a floppy parity. We're going to fix it the way we would fix a floppy parity. I'm going to take this and put it opposite. Now normally you can move it like this and say that it's opposite over here, but you know that the first move is to move this down the level over here, below this, on the bottom layer here. So we'll do our 2B, which is where it started off with anyway, and we're going to do our strategy. First thing we do a RedBull. Now when I do the RedBull, for your 2x4x6, it's going to be done like the 2x2, so we're going to split our F moves down the center here. Because when this comes up, it's going to bandage it right down to the center. So it's going to be 2R through here, 2B, slice it right through the center, 2B, 2U, L. Then 2 up, RI, 2 up, R, 2 up. You can see why we slice it down the center. 2F, R, 2F, LI, 2B, 2R. And now do a 2L to move this over to here. Do the RedBull again. It'll flip-flop these two. 2R, 2B, 2U, L. 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, LI, 2B, 2R. Do one more 2L, and you will find that these two are together, just like these two are together, and we just have to swing this down. Once more, 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, LI, 2B, 2R, and you'll find it's fixed. Don't worry about what might have happened to the center. We're not even there yet. Now that you've done that, go to the next layer over here. Just so happens you don't have a layer over here like you would with this guy, so we don't worry about that. Now we're going to take this in segments. These two over here, then these two over here. So starting off with this is in. So we have one set that's in, but these 3 here are not in. So what kind of a parity is this? This is a brick parity, not a floppy parity, because we have 3 that are out. One from here, one from here, and one from here while this is in. So the way this works is we're going to do the proper shuffling. That's going to happen with this. Now, I prefer to do it from this perspective as opposed to this perspective, just because that's how I'm used to. So I've got a red and white. That's not going to go over here. But I've got this yellow and white. That'll come over to here. So I'm going to call this a left-sided parity, because this will come to here. This yellow and orange will come over to here. to this yellow and orange here, and this white and red will jump over to here. So this is the left-sided configuration. This to here, this to here, rather this to here, and this to here. You don't have to necessarily memorize where it's going to be, just make sure it's back here, it's behind here. But this will come here, this will come here, and this red and white will come here next to this. So, left-sided parity. Start off with a 2F, then do a UI, 2L, U, 2R, UI, 2L, U, 2R. Do a 2F. Now remember what layer we're dealing with, which is this 2L in this layer, and then another 2F. Finish it up, now starting with the R, 2R, UI, 2L, U, 2R, UI, 2L, U. Then do a 2F, and then a 2L. You're going to find this is in, this is in, this is in, and this is in. So it fixes all of that. Now we just go a layer out. Well, you can see we have these over here, all these orange and whites. So let's find the other orange and white and just move it in. It's right over here. I move it in over here. And let's see what I have. All of these are in, all of these are in. This is out, and this is out. So what kind of a parity is this? To or out? This is a floppy parity. So we're going to fix this like a floppy parity. Let's move this to the opposite side. I prefer to do it like this. Now this is already on the layer below. So if it was over here, just across from it, just do a 2B to move it down. And now without thinking too much about what you're doing, do a RedBull, but it's going to be amongst these two pieces over here. These two are going to become RedBulls. These are going to be ignored. These have already been dealt with. We're going to pretend like these are fused together, and these are our right and our left. 2R, split it down the middle here. 2B, 2U, remember what layer we're dealing with, L. 2 up, RI, 2 up, R. 2 up, 2F, U, 2F, Li, 2B, 2R. And now we just do a 2L to bring this in line, and immediately do another RedBull. 2R, 2B, 2U, L. 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. We do one more 2L, and then we do it again. As you can see, these two are lined up, and these two are lined up as well. They're not the same color as this, but it doesn't matter as long as these are the same. 2R, 2B, 2U, L. 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. So now that we have that, these are fine and these are fine. To which you might say, well, wait a minute, all these are in and all these are in, but these two aren't. But that's okay, because this is just 4 that's out, so this is our typical odd layer parity, or rather even layer parity. So 4 that's out is even layer parity. We had 2, we put them in, we put these together with each other. Now if we wanted to reduce this entire edge segment, we just have a typical even layer parity, which is solved by the URF algorithm. So to the side, 2U, 2R, 2F, 2U, 2U, and 2F, 2R, 2U, and lo and behold, these are all reduced. So it looks like we may have taken out our 2x2 solve, but not really. That's easily placed. We can just put this over here, and we can see that all of our corners are all lining up. We're going to deal with these in a bit. And actually what we can do is we can put these in now as well. So this goes to here. This is going to be the yellow side. We're not dealing with the centers yet. So we're going to put we're going to flip-flop these two by the typical even layer parity. It's the URF'd, but we're going to split our first U here, and our second U is here. So when you're doing your URF'd, do the first U which splits right in the middle of your even layer parity, and the second U just above where that is. So when these two are out, this was our first U, and this was our second. When it's all of these, this is our first U, and this is our second U. So 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. So you can see these two have been flipped. So this is at the right side, this is at the right side, so are these. Now we just have to flip this red to here so it can match with this and this to here. Or alternatively, we can just do an opposite edge swap here to here. 2R, 2U, 2R, 2U, 2R, 2U. Same thing here. 2R, 2U, 2R, 2U, 2R, 2U. There's no edges here to cause any parity situations. Now what about these guys? This is in. These need to be swapped here. So I can take this, swap this to where it's supposed to be with the green. 2U, 2R, 2F. Split it here, 2U, 2U. Then 2F, 2R, 2U. This is fine, this is fine. These two need to swap. Now I can't do the adjacent edge swap over here because I'll swap these guys over here. So what I'm going to do is I'm going to just do the same algorithm here, the URF algorithm. Splitting here and here, so that's going to be 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. Now we can finally fix the centers, now that we have all of these in. Well, to do this portion here, the 2x2 centers, that's easy. That's just by positioning. I'm going to take this piece, and I got to move this into here. So I'm just going to position it to where I can do an R move to place it where it's supposed to be here, or an L move rather. So move this over here with a 2L. Now I'm going to do a U move to put it in the R position. So that's, in this case, it's going to be, or an F move rather, to put it in the proper R position. So I'm going to do an F, and that's going to place it over here. So I'm going to do another, I'm going to do a 2R. Then I'm just going to move it back to an FI, bring this layer back in, and then do my other F to bring this layer back in. You'll find we'll place these, and you're not going to offset anything else. So that's how you get these four. These four can be placed quite easily. Now in terms of the positioning here, we take a look. These two are out, and these two are out over here. Now if only we had a situation where it was symmetric. If these two are out and these two are out, well then we'd have ourselves just an even layer parity, and we do 2U, 2R, 2F, but with these guys. So this would be our, we'd start off here with, this would be our U, and this would be our middle U, and our F would be split right down here. So we can move these and swap these two, but after doing that, it's going to place the even parity over here, and then we just do the same thing, but this would be a U. This is a particular situation where we don't have that kind of a symmetry. So unfortunately, we find ourselves potentially with a brick parity over here. So here's what I would do. Get as much in as you can. So when I see this over here, if I were to do that kind of a parity, to bring an even layer parity, I'll go ahead and swap these two. What's going to happen is, at least I'm going to put this white one over here. This yellow one's going to come here, and this yellow one's going to come here. So what I'm going to have is I'm going to have this white one at least over here, and these two yellow ones over here. So whether you have two here or not, go ahead and swap these two with these two, because you know you can do that. It's a symmetric it's a symmetric 4-piece swap. So I'm going to do the even layer parity, 2U, 2R, and I'm going to split it down here with the 2F, 2U, 2U, then 2F, 2R, 2U. It will flip all these here and just place one yellow one over here. Now notice we placed the even layer parity up here. Just do it again. But now my F is going to be here instead of here. So it's going to be 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. Now what we have left is this and this. Now you may think, well, is this a floppy parity? Because you have to flip these two, and the answer is no, it's actually not. It's a brick parity because it's like a 3 cycle. You can use one of these to cycle around. So it's like this isn't supposed to be here. This is supposed to be, say, up here. So if I were to do the brick parity algorithm, left side, this would come here, which is great. This would come down to here, which you wouldn't notice any difference, and this would come up to here. So pretend like it's 3 that's out and not a floppy parity. You really don't get floppy parities with any of these inner areas. You only get brick parities because you have equivalency of colors with each side. So I can easily look at it as this coming, or rather this coming to here, this coming to here, and this coming to here. So I'm equivocating these pieces with each other, basically. So with that said, we do the brick parity, and just like with the other parity, we split it down here. So this becomes our U instead of this. What this is going to do is it's going to solve the center, but it's going to move the parity up here, which will easily be solved. So here's how I do it from there. This is going to be on the left side. So we start off with a 2F. Then because it's left, we start off with a UI, 2L. Now our L is going to be here. 2L, U, 2R, UI, 2L, U, it's always split down here now, U, 2L. Then we do a 2F, bring this up, remember our layer, to a 2L, and then another 2F. Then finish it up with a 2R, UI, 2L, U, 2R, UI, 2L, U, do a 2F, and a 2L. That effectively places this back in and moves the brick parity to here. 3 that are out. Not 2, which would be a floppy parity, not 4, which would be an even layer parity, but 3, which will be a brick parity. So now let's line it up so that it can do the proper exchanging. Red and yellow will come here. Orange and yellow rather will come here. So I'm going to move this to the back, and this red and white will come here. So we do one more left-sided brick parity and we are done. So we do a 2F, UI, 2L, U, 2R, UI, 2L, U, 2R. Then we do a 2F, 2L down here, 2L, 2F, then finish it up with a 2R, UI, 2L, U, 2R, UI, 2L, U, do a 2F, and then a 2L, and now we simply move this back, and you got it. So there it is, 2 by 4 by 6. This is another way of doing it. This is what I would call the classic way of doing it, which means you put it together quickly. You don't have to do any RIDIRDing it, but you do have to deal with parities. Among the parities that you have to deal with is you have the even layer parity, doing the URF algorithm, the brick parity, the even layer parity where you have 4 that are out, where you do the URF algorithm, the brick parity where you have 3 that's out and you do that convoluted brick parity algorithm, or the floppy parity where you have 2 out, where you just do 3 sets of RedBull algorithms with a couple of L's because you've placed one behind over here. The reason why I call those the brick and the floppy parity is because on the brick puzzles, those are the only parities that you get, and the floppy parities, those are the only parities that you get. With the ultimate shapeshifter, you get all of those parities. So there you have it. You can do it parity free just by doing reduction of all the corners, or you can do it with parity by doing this particular strategy. Once you do the 2 by 2 solve, some of the hardest parts of the strategy is getting this down from the floppy to the brick form, but you can use some of those techniques that I showed you. Now that this is mass produced, my suggestion, if you like puzzle solving, if you like strategies, get this puzzle, get this version, get the Calvin version of this. Try whichever technique you enjoy, but my hope is that with enough interest, you'll see a whole lot of ultimate shapeshifters out there. So keep on puzzling. Thanks for watching.